Hello everyone, today we'll be discussing about the memory areas in JVM. In this video, we'll explore where and how your Java program uses memory, how things have changed from older Java versions like Java 6, 7, 8 to Java 17 and today we are on Java 24. So how things have changed inside the JVM. So if you are new to my channel, do not forget to subscribe my channel for more such helpful tech videos. So let's move ahead. First, let's understand about what is JVM. JVM stands for Java Virtual Machine. If you want to understand JVM more in detail, like JVM, JDK, JRE and their internal working, you can refer to my complete video. I have added link in the description, so you can refer that. So let's get back to the video. So JVM is like an invisible computer which is placed inside your computer, okay, that understand how to run your Java code. When you write a Java program, the compiler turns your program into a .class file. Okay, the JVM takes those files and then runs them. But to do that, it needs some memory. Just like your brain needs space to think and remember things. So similarly, JVM organizes its memory into different sections or areas, each section for a specific job. Okay, so these are the JVM memory areas majorly that we know about. Okay, so the first one is the method area, then the heap area, then stack area, program counter register, and then the native method stack. So if we go in detail of each area one by one, so let's first understand what is heap area. Okay, so heap is basically the largest area, memory area, which consumes the largest area inside your JVM. So it's like a big toy box where all your toys like Java objects are kept. It is divided into some sections like the young generation for new object, the old generation for the long living objects, and the survivor space that acts like a checkpoint. Okay, so these are the main three areas inside the heap area. Okay, and there is one more thing inside heap area, that is garbage collector, or we know it as GC. It's like a cleaning robot inside it, and what it does is it just removes the unused object from the toy box to make room for new ones. Okay, so like if you're creating new object, every time it is added to the heap area. So once you are done with your functionality, then still those objects are there which are not referenced anywhere. Okay, but those objects are still consuming the space. So at that time, garbage collector comes into picture and it delete and remove all those unused objects, those do not have any reference, and cleans out the space for the new objects. Okay, and now the next is stack area. This is the one more important area inside your memory. So it's like a stack of plates, like we have placed plates on one on the top of another and like this. So when you call a method in Java, it adds a plate. When the method finishes, it's remove that plate. Okay, so it add, how you add your plates? Oh, when you put plate on the top of each other, so you put first, then on the top of second, then third, then fourth, then fifth, and once the execution complete, then you remove it like this: fifth, then fourth, then third, then second, then one, and this stack is empty now. Okay, but sometimes what happens is, if you keep calling multiple methods, if you keep calling a single method multiple times without stopping it, so you may sometime get the stack overflow error, that there are multiple stacks are created which are now the memory has do not enough space inside stack to create new stack for you. So then that's why you get the stack overflow error sometime. So if you see this slide, okay, so you can see here what it shows is, it's simply adding first main method, So main method is like it can be any method, but in Java our main method is gets executed first. So like first the stack is created for main method, and then from main, if there is another call for any method, then that method is placed. Like for example, inside my main, I have method called call A. Okay. Now from call A, I am calling another method call B. So another stack is created for call B as well. So it's like main stack created, then call A stack created, then call B stack created. Now once call B execution is complete, this is removed from the stack and it will come back to call A. Now call A method execution will complete, it will remove from the stack, and now finally the main method execution is complete and it will be removed from the stack. So that's how a stack area is managed. Now the next one is method area. So in Java 7 or earlier, the method area was used as a special part of memory called the permanent generation, or you call it permgen as well. Okay, it stored information about classes, classes static variables, and method definition. Yeah, so permgen had this problem. It didn't grow automatically, and it was running out of space very frequently. When so many of you, if you have ever worked on Java 7 or older version, you have noticed and faced this issue of out of memory many times. So this was due to this permgen. Okay, and then we have the meta space. Okay, so before Java 8 we had the permgen. Now from Java 8 and beyond, the permgen was replaced by the meta space. Unlike permgen, meta space grows automatically by using your computer's native memory. It is smarter, it is more flexible, and it is reducing memory errors in large application. Okay, and this change made the JVM better at handling modern and large application. Okay, now let's come to the other areas, like we have PC register and native stack. So the PC is program counter register. Okay, it's a tiny memory slot that remembers which instruction is being executed in a method. Okay, so when you run some method, there are some instruction written, some code is written. Okay, so for those instructions, we have this memory area which stores all those instructions. This program counter register. And the last one is native method stack. It helps Java talk to programs written in other languages. If your Java code calls C code using JNI, it goes through this area. Okay, so to talk to other native languages, this native method stack is used to keep space for those execution inside this native method stack. Okay, these are smaller but super important for performance. So now let's talk about how memory change over the new Java versions. So as we have discussed, in Java 7 or before Java 7, we had the permgen, which was limited and rigid, and now in Java 8, the major change came as metaspace, which replaced the permgen, which is more dynamic and reliable. And now in Java 11 introduce better garbage collector like JetGC and Epsilon, which is more scalable, and it is a low latency garbage collector. Okay, and its goal is to handle very large heap sizes. Okay, while keeping the pause time very small, typically under 10 millisecond. Okay, so this is very fast garbage collector type. And then in Java 17, a long-term support version is introduced with improved memory tuning, added native memory tracking, and it gave developers more control over the memory management. So that was all. Thanks a lot for watching. I hope you now understand how the JVM manages memory and how it has grown smarter over the time. If you like this, do not forget to share with your fellow developers. Thank you.